Alright, in this example it tells us to write the expression as a complex number in standard form. And standard form just means a plus bi, where a is your real, and this second part is your complex. In example 4a, it tells you to multiply 4i times 6i. So I'm going to multiply the constants. 4 times 6 gives me 24, and I times I gives me I squared. Remember, when you're multiplying with the same base, you add the exponents. Here, I want to explain what I squared is. Partner B tell partner A, what is I equal to? Macy? Just like that? With the radical. So what I'm going to do here is the problem says squared, so I'm going to rewrite the problem again, but this time I'm going to use the parentheses. I'm squaring both sides. This tells us that there's two of these expressions, and they're in the same house now. Does that make sense? And class, is there a pair? Yeah, the pair comes out, and your answer is -1. I squared is equal to -1. Now, you don't need to show all of your work here, but I was just trying to prove to you that I squared is equal to -1, and now we can use that. I can do a substitution here. So now I have 24 times -1. Remember, this is not 24 minus 1, because over here 24 is separated by the I squared by multiplication. There is no plus or minus. And class, 24 times -1 is? -24. -24 is our answer. So pay attention now that we are actually multiplying, and now we have to use I squared equals -1. In my second example, I have -2i times the quantity 3 plus 2i. All we have to do here is just distribute. That basically means -2i times 3 and a -2i times I. And we're just going to go through and simplify. Class, -2i times 3. -2i times I. Partner B tell partner A, what do you know about I squared? Leilani, what did we just learn about I squared? It's equal to -1. So now I have -6i minus 2 times -1. So class, what's -2 times -1? +2. So I'm going to rearrange them now. 2 minus 6i. So in these two examples, be careful when you're multiplying. I times I equals I squared, and I squared equals -1.